Today we're going to look at geometric series. And if you looked, we talked previously about geometric sequence. Geometric sequence is something like 1, 2, 4, 8, 16, and so on. The series that goes with that is I'm adding those terms together. So let's say I wanted to find out what 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 was. We could go ahead and just add those up. But you can imagine that wouldn't be a very good solution if there were 58 terms. I wouldn't want to have to carry that out that far to figure that out. Fortunately for us, there's a formula for that. And they do show in the book on page 643 how they developed this. But I'm going to skip that for now. We're just going to look at what the formula is for. So the sum of a finite, meaning a series that ends. I can't spell today, as if I could any other day. Finite series. And the formula is the sum of the first n terms is a1 minus a1 times r to the n over 1 minus r. Or sometimes we can factor the a1 out and write it as s sub n equals a1 times 1 minus r to the n over 1 minus r, where r is the common ratio. So if I were to do that with this one up here, I know that so what I need is I need a1, I need r, and I need n. There's 1, 2, 3, 4, 5, 6, 7 terms. So I would want to find what s of the first 7 terms is. So n is 7. A1 is the first term, which is 1. The common ratio, just take a term and divide it by the one before. In this case, that would be 2 raised to the n power, all over 1 minus 2. And after you have that, it's just a matter of using your calculator then. We're going to make a fraction, so we go alpha y equals a fraction. And then we're going to do 1 minus 1 times 2 raised to the 7th. And all of that's over 1 minus 2. And so the answer to that is 127. And if you were to add those up, that's what you would get. Now, if you wanted to use the other formula, it's really the same thing. I would just take and say s sub 7 is a1, which is 1, times 1 minus 2 to the n, which is 7, over 1 minus 2. Put that in the calculator. So again, you would just go, oops, if I move this over, alpha y equals a fraction, 1 times 1 minus 2 raised to the 7th, and on the bottom, 1 minus 2. And I'd still get the same answer. So let's look at some examples of the information that they might give us. Let's just look at a couple problems here. Let's say I gave you this: find, you evaluate the geometric series. So the first one we're going to look at is, what if I wanted 4 plus 8 plus 16 plus 32 to n equal to 9? So again, our formula is s sub n is a1 minus a1 times r to the n over 1 minus r. I know that, so the information I need again is a1, I need what r is, and I need what n is. I know that n is 9. I know that r, 8 divided by 4, is 2. and a1 is 4, the first term. So now it's a matter of just substituting right in here. Sum of the first 9 terms is a1 minus 4 times 2 to the 9th over 1 minus what r is, which is 2. And again, it's just a matter of taking your calculator. We're going to take and again make a fraction. On the top, we're going to go 4 minus 4 times 2 raised to the 9th over 1 minus 2. And the answer is S of 9 equals 2044. And there's your answer. All right, now sometimes they may not give us all of that information. They might give us information in a different manner. They might give us information like this one, problem number 2 here, where they give us that a1 equals 4, r equals 6, and n equals 7. We want to find the sum of the first 7 terms of this geometric series. So what I do is, again, I need my formula. If I go back up here, I need a1, I have that. I need r, I have that. And I need n. I have all the information I need. Now, it's just a matter of plugging in there. So S of 7, n equals 7, is equal to a1 minus a1 times r to the 7th over 1 minus r. Just take your calculator then, and again, we're just going to put that in the calculator. I'm going to go alpha y equals enter. I'm going to go 4 minus 4 times 6 raised to the 7th, and all of that is over 1 minus 6. And I get 223,948. And there's the sum of the first 7 terms. All right? Well, one other type of notation that can be used for this is sigma notation. We talked about that before with arithmetic sequences. Now with geometric sequences, they could look like something like this. You got the sigma sign, which means a summation, and it goes I equals 1 to 7 of 2 times negative 5 to the n minus 1. Anytime it's in that form, this term that's right here is a sub 1. This thing that's being raised to the power is r. And n is just a matter of counting. If I started at 1 and went to 7, how many terms is that? Okay, so if it starts at 1 and goes to 7, obviously n equals 7. And again, for our formula, a1 minus a1 times r to the n over 1 minus r. The 3 things I need are n, a1, and r. Well, I have those things, right? Except, so a1, if I put 1 in there, 1 minus 1 is 0. This to the 0 power is 1, and 1 times 2 is 2. So r is this term, which is negative 5. Now I plug it in the formula, and I get sum of the first 7 terms is equal to a1, which is 2, minus 2 times negative 5 to the 7th over 1 minus negative 5. Be real careful with the sign. Minus a minus is a plus, or actually you could just enter it just the way it is. Just take your calculator, and we're going to enter that in there. I won't even change these minuses. I'll just leave it the way it is. Just let the calculator take care of it. Okay, so I go alpha y equals, and there's my fraction. I go 2 minus 2 times negative 5, negative 5, been using a different kind of calculator, And actually I need parentheses in there. Because I want it to be negative 5 raised to the 7th power. And over that, that's 1 minus parenthesis negative 5. And the answer is 26042. And there's my answer. Okay, so sigma notation is just a shorthand way of writing it. And that's all it really is. I'll do one more example of that. Well, actually, that's a pretty good example right there. If I gave you a sigma notation, sometimes it might be something like this, and they'll just have like negative 3 to the I minus 1. Well, I guess this really needs to be an I on this problem, not an N. Just so it matches with that variable. Doesn't change anything else. So from this, I know if I count from 1 to 5 that N equals 5. A1, what is A1? Well, it's the number that's right here. And since there isn't a number, I could put 1. And so it ends up, if there isn't a number in front of that parenthesis, that's what your first term is A1. And then R is going to equal negative 3. And now we could plug it in the formula. Sum of the first 5 terms is A1 minus A1 times R to the N over 1 minus R. And so then we just go alpha y equals fraction 1 minus 1 times parenthesis negative 3 raised to the 5th, and all of that's over 1 minus parenthesis negative 3. And the answer is 61. And that's what we're really doing today on today's assignment. So try it. If you have questions, please make sure you ask. Send me an email or comment in classroom.